Okay, so last time we started to talk about the basics of the moment of inertia, so how we can actually calculate them. Just very quick reminder, the moment of inertia about x integration of the y squared dA, or integration of x squared dA, or if it's going about the origin, it's going to be r squared dA. So these are the three equations that we have for calculating it. And then we talk about the parallel axis theorem. So it says that the I about any x-axis is I about the axis that passes through the central plus the a d y squared, and I about the y-axis about y passing through the central plus a y dx squared. And j, sorry, this one is j about. And again, j about the axis will be j that passes through the centroid plus the a and d squared. So remember that I said we are using these ones more frequently because usually the I about the axis passing through the centroid is given. So this one usually is given. So we can just use that one to calculate IS. I will show you that. We always can use this general equation, that's fine. But usually these are easier to use rather than the one on the top. Then we're going to show you a couple of them to see how it works. So, first example.
Which page?
511. So, just simple case. We want to look at it. How we will do it for the cross section. If we have a beam that has a cross section of a rectangle. So we want to look at that cross section of the rectangle. See how we can find the moment for that. So if I have a rectangle like this, and it's going to be the x-axis, y-axis. So this is my cross section, that's the x and y axis. And the first thing that it wants us to know that how much is the I about the axis passing to the center. So the centroid is here. That's the x prime. This is the y prime. So it's the axis that's passing through the center. So I want to know how much will be the I about the x prime. So basically, this the question is that that's what we want for. So if I want to find that using this general equation, so again, about any axis I can use this equation. About any axis. So it can be x prime, or any axis, so I can use those equations. So if I want to find the ix integration of the y squared dA. And now I'm just write it so it's good. X prime is also, I can use the same equation. So I can write it about any axis I want. So if this is the case, I have to find the dA. So remember that I told you in here, if we want to find about the x or x prime or t, the dA should be parallel to that axis. Unlike the centroid that we could get any dA and calculate both x, the x and y for the centroid, here we cannot. Here we have to choose the element parallel to the x or x prime. So here x is horizontal, so our element should be horizontal. So I have to go ahead and get a horizontal element like that. It's going to be dy. And this side of it. So these things, the entire one is the b, so this is b. H, and then the entire one is h. So dA for this one, how much is dA? The d, dy, correct? The dA is the area of that, the area of this. So the width of the element, which is going to be times dy. That's going to be my dA, so it's going to be b dy. And by the way, here, because I'm doing for that, it's going to be y prime squared, because I just goes to that. So I x prime would be integration of the y prime. And this is also going to be y prime. So it's going to be dy prime. Y prime is going from integrating over y prime. 0 to
H12. Yeah.
That's correct, but not this one.
Dy minus y prime.
Okay, here. I want to integrate from here to here. So let's put it this way before. Assume this is my cross section. Don't get yourself confused with x. This is the x, this is the y. Assume that, and I'm integrating y about x is the y squared dA, which will be y squared b dy. Okay? So y here changed from here to here. So here is going to be, how much is going to be done here? Let's go down.
H2. Negative.
So, and then goes up to plus h2. So it goes negative h2 to plus h. So, because I just have two axes here, I put the prime there. That don't let that prime confuse you. It's basically this is what I'm doing.
How come the square got taken away from the y?
Oh, okay.
Oh,
Okay. So yeah, forgot. So it's gonna be the y prime is going from negative h squared to y prime is equal to h squared. So if when you're doing it, if those prime make you confused, just get rid of them. Do the calculation. So b is a constant when it goes up, when we go out. Right? And then you have the integration of basically the b integration of minus h2 to h2 y prime squared dy, which if you do that comes out as 1/12 of bh cubed. So if you go to the back of the book, here, and look at here, and then say it calculates the I, and I about the x is 1/12 of pH. So usually that's why I said the I about the axis passing through the centroid are given to us. We know then how much is the I passing through the centroid. So this time we calculated, but because it's a non-geometrical shape, we just refer to the table to get that value. Now, assume I calculated, but assume it's known, it's given to us to the table. And then we are asked, calculate the I about any given axis. Let's here be that axis x. This is a known. Now I want to know that how much would be the I about the x-axis. I know it about the x prime. I want to know how much it's going to be about the x. So one way of doing that is that, again, I go ahead and calculate this integration. Can do that. I can go ahead and calculate this integration. This time the y will go from 0 to h. There's one way of doing that. But it's easier way to use this equation. So this equation is going to be I going through the centroid plus the a dy squared. So if I want to calculate that, how much is this part? 1/12 of bh, so it's going to be 1/12 of bh cubed. The area, alright, so the area is just b times h, so that's going to be the bh, that's the area. d sub y, d is always the distance between the two axes, the axis we know to the axis we want to find about it. D is the distance between two axes, the axis we know about it to the axis we want to find about it. So here we know it about the x prime, we want to find it about the x. So this is going to be d sub y. Distance between two axes. So the distance between two axes, the dy is half of the height. It's going to be And so if I, and it's going to be the power of 2. This is going to use up 1/3 of E H cubed. Can do the same thing for the Y, but since the rectangle is symmetric, it's going to be just replace switching B and H. Instead of BH cubed, it's going to be HB cubed. So, couple of things. First of all, as I said, assume I have a beam that looks like this. And that x prime, y prime that I'm saying that is the x prime, y prime. So that's the moment of inertia about that cross section that I'm calculating. So I want to know if it bent about the x or if it bent about the y, what would happen. So when we are, anytime we are talking about the moment of inertia, means that we have a we have a beam, and then we want to find it about the cross section. At the same time, in this case, for example, the x is here, and the y is here. So, can you visualize it, what we are doing? So there's a beam, we cut it, we want to see the cross section of that beam, how much is the moment of inertia for it? The next thing is that you're gonna eventually memorize this. It's very common formula that you're gonna use. For the cross section that I have, if I have the rectangle cross section, it's gonna be B and H. And for the axis passes through its center, x prime, y prime. The I about x prime is 1/12 of BH cubed, and I about the y prime is 1/12 of H. B cubed. The solution. If I have them like that, and this time I have the x and y axis sitting at the base of them, like here. And again, it's the B and H. I about x is 1/3 of BH cubed. I about y is 1/3 of H. So you don't need to memorize them, but you're gonna use them so many times in different courses that eventually you memorize it. Any question? So this is how it's parametric, how it things look like, but I'm going to go through some example that have some how we can do. We have numbers or okay. So suppose you have a cross section of the beam like this. So that's cross section.
Which page are you on first?
512.
I'm confused.
And X and Y 100 millimeter, 200 millimeters. 100 millimeter. 200 millimeter. Equation for that Y is equal to X. So here we're asked to calculate the height about x-axis. So once I bought the x-axis, so I have to go ahead and find the dA parallel to the x-axis, because I want to find it about the x-axis. So I have to go ahead and get the dA down to some levels. That's only my dA. So this is the dy. The point under this point here, the coordinate for this point is x and y, because it's on the curve. The coordinate for that is x and y. So now I want to find the dA. To find the dA, I need these lengths. Correct? So how much is this length?
100 minus x.
Yep. So if I want to draw that, so up to here, this is x. And from here to here, it's going to be 100 minus x. So that's my, so yes. So the dA, if I want to write it, dA is going to be 100 minus x dy. Right? So, can I use it? No.
Create a function y.
Yeah, because we have the dy, we have to rewrite everything as a function of y. So I have to get rid of x here. And I know that, so I have this equation here, so I know that the y squared is 400x. Therefore, x is y squared divided by 400. So, I can go ahead and say, okay, I know these two, so write it here. So dA would be 100 minus y squared divided by 400 dy. Now everything is a function of y. Agree? So now I will go ahead and have the equation of that I about x is y squared dA. Therefore, I about x is y squared dA. So it's going to be y squared, and the dA is 100 minus y squared, 400 dy, and the limit for diffraction you're integrating over y. So you have to start from the bottom of the cross section to the top of the cross section. So let's start from 0 to 100. So it's going to go y from 0 to y equal to and plug it in your calculator. Double check it for right equation. If I write it correct, it should come out to 107 times 10 to the 6. Sorry.
Yeah.
And remember I said that the I is usually going to be very, very large number. You can see, because it's going to be to the power of 4, it becomes really big. Next example is asking, what's the moment of inertia for the circle? About the axis passes through its center. So if I have a circle, see if I can draw a circle. If I have a circle, almost circle, and I have x and y passing through it. X, y. I want to find the I about x. So the circle, the equation of circle, x squared, y squared, equal to the r squared. Call it a, so it's a squared. So a is the radius. For some reason, it choose r. So similar to this one, I about the x, so the element should be parallel to the x. So if it was I about y, the element should be y, parallel to the y. So if I go ahead and say, okay, this is my element. And this is going to be the dy. So I need the dA. To dA, I need the length of the element. I have the height of that, I need the length of that. This point, what's the coordinate of this point? X and y. What's the coordinate of this point? Negative x and y. So the negative x and y and x and y. So this distance is going to be x. This distance is also going to be, distance is going to be x. Agree? So the dA is going to be 2x dy. Again, I have a dy, so I have to write everything as function of y. X cannot be, I cannot use the x, I have to confirm it as a function. So I have to come here and say, okay, I have this x squared plus y squared, a squared. So I want to find the x as a function of y. So x is going to be a squared minus y squared, the power of so now, put these together, the dA would be 2a squared minus y squared, square root of that, dy. And now if I go ahead and put it here, ix square root of y squared, integration of the y squared. Here is x. integration range is going to be from the lower to the top. So the bottom is negative a, that's the a. That's going from negative a, so minus radius to the plus radius. But remember, in problems or exams, these are going to be numbers. So you are not doing this integration, you just need to know how to do it numerically.
Is that 17? No, that's pi of 4. Okay.
So, any question about, in general, how to calculate the moment of inertia general case, if you're given any irregular cross section? One more time, remember, these are the cross section of the beam. As you have a beam that cross section is 0. Or somehow you have a beam that cross section is X.
That'd be a weird cross section.
Yes.
It's weird beam.
Remember when we talked about the centroid, we first started to talk about how we calculate the centroid for the given general shape with the integration. And then we said, but maybe we want to focus on the geometrical shape that we know. If our cross section made of, for example, the rectangle, triangle, some kind of geometrical shape that we know, it's easier to, instead of integration, go ahead and calculate the centroid for each of them and just add them together to see where it's going to locate it. The same thing for moment of inertia is like that. If the shape that we want to find the moment of inertia body is made of non-geometrical shape, we will go and calculate the moment of inertia for each of those shapes and then just simply add them together. For the moment of inertia, remember, it's always going to be positive. And so we just simply add them together. So, for example, assume I have the I cross section. I cross section like that, and I was told, okay, go ahead and find the moment of inertia, what the axis is. So one way of doing that is just go ahead and try to do that integration for that cross section. It gives you the correct answer. But the easier way of doing that is that I will go ahead and say, is it made of the shape that I know? Sure. So I can break it down into 3 shapes. I can go ahead and say, if I break it down here and break it down here, This is one area that I know. And then I can say this is another area I know. And then this is another area I know. So I can break it into the three known geometrical shapes. The very first example we did was how to find the moment of inertia if there is a rectangle, correct? So now I have three shapes. So I will go and say this one is equal to my axis plus plus. So this is my x-axis. And I'm going to have three shapes of that. So first one is the one that's sitting out there. That's the first one. The second one is the vertical one sitting here. And the third one is the one that's sitting down here. So that is equal to these three. Agree up here? So I can break it into these three. Now that I have them, I have to go ahead and find the moment of inertia for each of them separately. So if this is an Ix, so that's going to be the this is the Ix. It's going to be the Ix for the part 1 plus Ix for the part 2 plus the Ix for the part 3. So I have to calculate them, so it's going to be equal to that. So if I calculate the Ix for these three, I would have that. So for the first one, if I want to calculate for the very first one, the Ix for this one, I'm going to do it. It's the X. The axis passing through the center, X prime, Y prime. And this distance, I call it dy for the first one. So Ix for the first one, is the Ix what it's passing through their centroid plus a dy for the first one, which would be, again, Ix1 would be, what was the moment of inertia for the one that going through the centroid of the rectangle? 1/12 of BH cubed. So it's going to be 1/12 of BH cubed for the one plus the BH for the one dy for the one. Right? So I will find this, I will find this one the same way, I will find this one the same way, and then I will add them together. If there was a hole, it's going to be negative.
It's the same process, just subtracting.
Yeah, it's the same process, just there. So moment of inertia for the hole is negative, just remember that.
So with the moment of inertia for the rectangle 2, just have no dy.
So again,
For the number 2 rectangle, would its dy just not be a thing since it's all on?
because its centroid is right there.
Yeah. So it just not have a dy.
It doesn't have any dy, so it's just gonna be 1/12 of ph cubed. And this one also gonna be A1. This is the A1.
The dy would be negative for that last one.
Ty is the distance.
Oh, so it's a magnitude. Yeah.
That's the dy for the here. Remember, except for the hole, your moment of inertia, the entire calculation will be positive. Except for the hole. Question? Example with number. So let's take one example here. So want the moment of inertia for I have shape as a moment at the center. This is the x-axis. And want the moment of inertia of this shape. What is the x-axis? So it's going to be simple. 5. Hundred. And the radius is 5. So, want to calculate the moment of inertia of that blue cross section that there is a hole at the center of. So I'm going to make it again equal to, it's going to be equal to, break it into the known shape. So I have two known shapes. One of them is the rectangle, and one of them is a circle. Make sure that you're at the same location at the origin shape. So this is the x-axis. And so ix here is equal to ix for the first one plus the ix for the second one. So the centroid for this one is here, and the distance between the axes, this distance is dy for the first one, which is 75. The centroid for this one is also going to be at the same location. And the distance also is going to be dy for the second one is going to be 75 as well. Here is the hole, so I have to put the minus, because that's the hole is negative, so it should be minus. So for the rectangle and for the circle, I know that. So for the rectangle, it is the B H and that's the x prime. I about x prime was what, 112, so
EH.
for the circle, x prime, if this is the R, this distance is the R, the I x prime would be I R cubed divided by 4, something like that. Okay. So here, for this one, so Ix is equal, for Ix1, how much that? The 112, so BH cubed over 4. Ix1 is I about x prime. Ix1 is I about x prime 1 plus the A1 dy1 squared. So it's going to be I about x1 is 112, so E times H, which is going to be 100 times 150 cubed plus A is 100 times 150 and dy 1, so it's going to be 75 squared. So just write the Ix2 is going to be I what is centroid plus its area. So I about the centroid is this, P is I R is also 25, so that's I, plus its area, it would be I times 25 squared. And then the I is subtracting these two from each other. So the Ix is Ix1 minus Ix2, which would be 1 and 1 times 10 6. So remember this. So this part is the I about the X prime for the first one. This is the I about the centroid for the second one. This is the area for the first one. This is the area for the second one. And EY1 squared. And this is the EY2 squared. Remember that for the rectangle, we also knew that, I didn't put it here, just try not to confuse you, but we knew that if this was the x-axis, that was 1/3 of BHQ. We could have directly used that equation. Because for the rectangle, we know the moment of inertia about its base. So instead of writing that, we could have directly write 1/3 of BHQ. Instead of this, we could have write 1/3 of BHQ. Question? So most of the moment of inertia problem you're going to deal with is going to be like this. It's going to be a known shape that we know the moment of inertia about the centroid. So we break it down. We calculate the moment of inertia at the centroid, then we calculate them about the axis we want, and then we add them together.